bonding, and today we're going to look at naming ionic compounds, right? But we're going to use something called the stock system. So we'll explain what a stock system is right now. Okay, let's go. So we're looking at stock system. Okay, alrighty. Now, naming. Okay. Bam. So we asked in class, right? If someone asks you, right, to write the formula for something like iron chloride, what would you do? All right. So we know iron is Fe, right? And we know chlorine is Cl. Now, for the negative ion, or negative monatomic ion, we always look at the top number on your reference table, right? It's no problem, right? It's -1 right there for the chlorine. Bam. Now, we asked, what do we use for the iron? Now, many students said, you know what? Iron is here. Okay, we have Fe. I see a +2 there. I see a +3 there. We're going to use a +2 because we always use the top number. Well, the top number is a charge for the negative ion, right? But it just so happens these guys are also called oxidation, okay, oxidation states. And the rule is, guys, that any time you have a metal or a positive ion of a metal, okay, with multiple oxidation states, you have to indicate which oxidation state it's in when it makes a compound. Because the funny thing is, they both can make iron chloride, right? And it will not be the same compound, with different physical chemical properties, alrighty? So, you have to indicate what oxidation state it's in using Roman numerals, and that's called the stock system, okay? It's a way to figure out which particular oxidation state metal ion, a positive metal ion, okay, because metal ions are always positive, right? If they have multiple oxidation states, I'm gonna write that down, please. Okay, right here. Multiple oxidation, okay, it must have multiple oxidation states. Why am I stressing that? Because if you have something like sodium chloride, right, and you look in the box for sodium, all right, Na +1, or you have something like calcium bromide, right? You look in the box for Ca, it's just +2, right? These guys only have one oxidation state, so you don't need to identify which oxidation state it's in. So you don't use Roman numerals for guys like group 1 and group 2 metals. But it's typically for the transition metals with multiple oxidation states that we use stock system. Now before we jump into the examples, okay, you got to know your Roman numerals, right? So here you go, all right? You see this? 1, 2, 3, 4. IV is 4, right? 3 lines is 3, 2 lines 2, and 1 line is 1, right? 5 is just V. Like I said, it's 1, 2, 3, 4, 5, all right? Okay. Then we got VI, that's 6. V and 2 I's is 7. V and 3 I's is 8. Then IX for 9 and X for 10, okay? We rarely use 10 and 9 in those guys, right? But just make sure you know the first 10, we're good to go. All right, so what we can do now, we can jump into examples, all right? So what are we doing today? We're doing something called a stock system. What's a stock system? It's using Roman numerals to indicate which oxidation state a particular metal ion is in, okay? All right, in a compound, all right? So no, we're not gonna guess, we're not gonna mix and match. We're gonna calculate, all right, the oxidation state for the metal ion. Now the rule is this, folks, okay? Is that what you do, you find the total, all right, negative charge first, all right? We'll do some examples if you don't quite get what I'm saying right now, but we'll find the total negative charge first, then we'll find the positive charge, all right? And the third step is divide if necessary. Alrighty? So rather than talking about these steps right here, let's do some examples and incorporate them. Okay, so moving on. Okay, pull this over. Okay, I think that's TiBr3, okay? Now, what's the first thing you do? You name it as if you were naming a normal, regular compound. Yes, ionic compound, metal on metal. So we know Ti, right, is titanium. So you write that down someplace. Titanium. Okay? And you know Br is bromide, right? It's a non-metal ion. Okay, so it gets an IDE ending. Titanium bromide. Now, guys, this would have been your answer, right? If titanium didn't have multiple oxidation states. But it just so happens it does, okay? So you're not gonna panic. You look at the box of titanium, right? You'll probably see multiple oxidation states. Now, once again, guys, you need your reference table, guys, okay? So you're not gonna guess whether it has multiple oxidation states. You look, find Ti, see how many oxidation states it has. It has more than one, you're good to go. You gotta use Roman numerals. You don't guess. If you see it has only one oxidation state, you don't need Roman numerals. Okay, so the first rule says what? We're gonna calculate the total negative. So what do? Bromide is from bromine, right? So you look in the box for bromine, right? You look at the top number is -1, right? No problem. So you ask yourself, how many Brs do I have? I have 3 bromines, right? So we got 3 down, that's the total number. 3. You times it by the charge of the bromine, right? So you got 3 times -1. So 3 times -1 is -3. Take a breath. So -3 is the total negative, right? So since these compounds, when they would remember the crisscross method, okay, we're trying to get these guys to be neutral, all right? So what plus -3 gives us 0? Okay, that will be +3, okay? Now here's the deal, guys. When you're doing the Roman numerals, right, it's always representative for one metal ion, okay? Always for one. It just so happens we have one Ti right here, so this +3 is for that one Ti. Now, all you have to do now is represent this +3 for that one Ti with Roman numerals. You're good to go, you're done. So you put your Roman numerals right here. 1, bam, bam, parentheses around it. Titanium 3 bromide, done. Okay, you move to the next problem. Next problem, okay, is PbSO4. Now guys, remember, chemistry is foundational, right? So the stuff we learned before in terms of binary ionic compounds and ternary ionic compounds applies here again. You got Pb, you got S, you got O. So automatically, right, that's a ternary compound, okay? It's 3 or more different elements. So what's the rule for that? Automatically, you're gonna have a what? You're gonna have a polyatomic ion. And what table do you find polyatomic ions on? You gotta go on table E, right? Okay, good. So you look on table E, and when you look on survey table E, we did this before, right? You'll see that there's SO4 on table E, right? That's a whole ion, that's a whole polyatomic ion carrying a charge. And it just so happens SO4 name is sulfate. So you write that down. Sulfate. Okay? What's Pb's name? Pb's name is lead, right? You write that down, lead. Lead sulfate. Notice the first guy always stays as is. Positive ion stays as is in the name. And polyatomic ion name, we don't do any modifications. So lead sulfate, right? And once again, that normally would have been our answer, but it just so happens, right, when you look in the box, right, for lead, it has multiple oxidation states. It has more than one oxidation state. You don't guess which oxidation state it's in, you calculate it. What's the rules? You look for sulfate, right? Now, the tricky thing is this, guys. You have one SO4 here, okay? Be careful, because sometimes students say they got 4 SO4s. No, you got 4 oxygens, but you have one SO4. Remember, it's a polyatomic ion carrying a charge. So you got one SO4, and it has a charge of what? It has a charge of -2, because when you look on your table E, right, you're gonna see SO4 -2. So that's the charge right here, and this is the whole unit carrying that -2 charge, okay? So it's one SO4 carrying a -2 charge. So 1 times -2 is -2, right? Take a breath. What plus -2 gives you 0? Okay, simple question, no calculators. +2, right? Bam. Now this +2 right here is for this one lead. We're good to go, all right? We just put a 2 right there, bam. Roman numeral 2 representing the positive 2. The answer is lead 2 sulfate. You're good to go, you move on. Let's do the next guy. All right, so guy in the middle right here, Cu2O, all right? Name as is, regular, copper, right? Cu is copper. Now guys, if you're not familiar with some of these names of elements, you don't panic. There's table S to help you, all right? You find the symbol on your reference table with the atomic number. You flip the table S, you scroll right down, bam, you find it, the name's right there. Okay, so table S is very, very helpful. All right, you got copper, right? O right here, negative ion, monatomic, oxide, bam. That was a normal name, but you look in the box, right, on the periodic table for copper, Cu, it has multiple oxidation states, so you gotta use what? You gotta use Roman numerals. You don't panic. You got one oxygen here, people, all right? So, you got one oxygen. You look in the box for oxygen on your periodic table, O, right? You'll see a negative 2 there, okay? So 1 times negative 2 is negative 2, all right? What plus negative 2 gives you 0? Positive 2, all right? Bam. Now here's the deal, we gotta be careful. Before we place the positive 2 there, we gotta make sure that what subscripts we have here. In the previous examples, right, it's only one was a subscript, yes? But in here we have Cu2O. So we got 2 coppers, right, that are equal to positive 2. And remember what we said, right? We always represent for what? For one metal ion. So if 2 coppers are positive 2, 1 copper is going to be what? Positive 2 divided by 2, that's positive 1. Okay, so be careful. If there's a subscript like greater than 1, you got to divide by it. All right. So that positive 1 now goes here as a Roman numeral. Just put a line, bam, bam, parentheses, you're good to go. Copper 1 oxide. All right? Moving on. Let me put a little line right there. This is Sn, parentheses, NO2, okay, parentheses 2, okay? Now here's the deal, guys. Don't panic, right? It looks confusing. You take a breath. I got Sn, I got N, I got O, right? So automatically, what do you know? You know that there is a polyatomic ion in here somewhere. You gotta look on table E. You look on table E, right? You're gonna see NO2. NO2 just so happens to be the name right off table E. It happens to be nitrite. Okay, so notice I'm not saying nitrogen dioxide, no. It's just nitrite, bam, done, okay? Sn, what's Sn? Sn is tin, right? And once again, what I said, if you're not sure about the particular names, find it on the periodic table, find the atomic number, look on table E, and you're good to go. Or table S, you're good to go. All right, so tin nitrite would have been the answer, but since tin, Sn, has what? Multiple oxidation states, we got to use Roman numerals, right? So we're this is a pattern here. So you look on table E, right? Nitrite just so happens to be what? NO2 minus 1. Okay, you got 2 of them. You got to be careful here. You got 2 of them. You got 2 nitrites. All right? So 2 times negative 1 is negative 2, right? Now what plus negative 2 gives you 0? Positive 2. Bam. All right? There's only one tin there, so this positive 2 goes right there. Bam. Roman numeral 2. Tin 2 nitrite. You're done. Okay? Alrighty. Got 2 more. Snap these guys out. CO3. Alright? So what do we have here? We have 1, 2, 3. You got cobalt, carbon, and oxygen. 3 different elements. Gotta look on table E. Look on table E. You're gonna see that CO3 is there, and the name of that guy is carbonate, right? Carbonate. No modifications needed. You read it as is. CO on your periodic table. Look on table S if you don't know what it is. It's actually cobalt, right? Bam. Would have been the name. But since cobalt, when you look in the periodic table, right, CO has, oh goodness, has multiple oxidation states. Gotta use Roman numerals. How many carbonates do we have here, people? We only have 1. So 1 times negative 2. Remember, on your table E, right, it tells you the charge of the polyatomic ion, right? So carbonate is negative 2, all right? It's negative 2, all right? 1 plus negative 2 gives you 0, positive 2. All right, bam. So this 2 goes to that 1 cobalt, cobalt, 2 carbonate, you're done as you're winding down. NiPO4, all right. You got Ni, you got P, you got O. It's a ternary compound, remember? 3 or more, okay? Look on table E, PO4 is what? PO4 is phosphate, okay? I'm not making up names. I'm following the protocol, following the rules, and make my life simple. But you gotta know the rules, right? That's the thing. So that's the thing with practice, guys, all right? You gotta practice making mistakes. Oh, now I know the rules. Okay, good, no problem. That's phosphate. PO4 is phosphate, and I just so happens to be nickel. Okay, nickel has what? Nickel has multiple oxidation states. Phosphate, PO4, right? The whole unit carries a charge of what, guys? And you look on your reference table, table E, it carries a charge of -3. Okay? It carries a charge of -3, right? Bam. So we got 1 whole phosphate right here. 1 phosphate times -3. 1 phosphate times the charge. That charge is going to be -3. Total negative on this side. What plus -3 gives you 0? +3. Okay? This +3 is for that 1 nickel. Okay, so you put the Roman numeral 3 there. You're done. Parentheses, nickel 3 phosphate, and you're done. All right, guys. One last thing. Reverse crisscross, right? Works a lot of times in these examples. But the best way to do these, guys, is actually doing these simple calculations and being definitely sure about the answer every time. Reverse crisscross works most of the time, okay? But you don't want to be correct most of the time. You want to be correct all the time. So take that little extra time, do the calculations, figure it out, you're good to go. Remember, you got table E at your disposal, you got your periodic table, use your reference table to your advantage. It's a tool, use it, okay? All right, guys, as always, hard work but sacrifice equals success. Take care.